Alright, so let's look at this problem. Find the current through a loop needed to create a maximum torque of 9 Newton meters. The loop has 50 square turns and that are 15 centimeters on the side, and they're in a uniform field of 0.8 Tesla. Alright, so now let's do a diagram first. So the loops, it's square, okay, and if it's carrying a current in this direction, the magnetic moment, current carrying loop of course acts like a magnet, and that's the direction in which the magnetic moment points. This just means that that's the North Pole and that's the South Pole. Okay, so this loop is behaving like a magnet where the North Pole is above and the South Pole is below. Okay, and well, I'll tell you this. The torque will be maximum when the magnetic field is in the plane of the loop. So what the loop wants to do is, when you pass the current, the torque wants to turn the magnet towards wants to align the magnet towards the magnetic field. Okay, and the torque is given by this equation. It's mu cross B. Okay, and mu is the magnetic moment is given by N I A. Okay, where N is the number of loops, I is the current, and A is the area of the loop. Okay, so what we want is, so the maximum again, maximum torque happens when and the angle between the magnetic moment and the magnetic field is B. B is 90 degrees. Okay, so the magnitude of the torque is mu B sine theta, where theta is the angle between the two. Again, this would be theta. Alright, so tau max is mu B. And you want this to be 9 Newton meters. Okay, so what is it that we want? Find the current. Okay, so tau max is mu B NIA B. And the area of a square, of course, is length square B. So I is tau max N L square B. Okay, let's see, what is this? 9 Newton meter. We have 50 loops and 0.15 meters square, and the field is 0.8 Tesla. Alright, so let's add a page. Okay, so the current is equal to, you can see from this expression, the higher the current, greater the torque, greater the maximum torque. Okay, so 9 divided by, okay, so you need to pass a 10 amp current to get that torque. Alright, is there anything else? No, that ends that problem. Okay.